All right. Hello, everyone. My name's Ben, and I'm an iOS engineer at Yelp. And I'm really excited to be back at iOS Conf in Singapore to talk to you all about writing Swift while living on Objective-C. And by that, I just mean working in an Objective-C code base while transitioning to Swift. But before I get started, I just want to quickly talk a bit about Yelp. So who here has used the app before, just by a show of hands? Great. Well, for those of you who don't know, Yelp's mission is just to help people connect with great local businesses. And to give you a sense of Yelp scale, every month Yelp sees 92 million unique visitors come from mobile. And since Yelp's inception, Yelp's users have written 108 million reviews. And in terms of mobile search, 72% of all searches on Yelp come from mobile. And internationally, we're available in 32 countries, and we've been in Singapore since September 2012. Now, the Yelp app launched with the App Store back in 2008, and since then, the app has always been written in Objective-C. But in January of this year, we decided to start transitioning to Swift. And one of the core reasons we decided to do that is because of the added type safety around nil pointers, specifically. So to give you an example, there's a huge difference in Swift between declaring a string that might be nil and a string that can never be nil. Now you can compare this to Objective-C, where you can do things like create a URL from a nil string, even though this doesn't really make sense. But if you try to do this in Swift, you'll get a compiler error, because in Swift you can declare that the URL API only accepts non-nil strings. This is a huge advantage over Objective-C. In Swift, you have a lot more power in terms of what you can declare as good and bad inputs, and then get feedback about that at compile time. Now, it may not be immediately clear why this is so important in terms of transitioning to Swift and how that's going to affect your app and your end users. Because, at least for us, the app in Objective-C looks and behaves pretty much exactly the same as the app in Objective-C with a little bit of Swift mixed in. But what we hope to get out of this transition is the ability to learn a lot more about our app at compile time. And so that's going to be our goal, is we want to increase our ability to learn about new issues about the app at compile time. And we're going to do that by leveraging Swift's richer type system to give Swift as much information about our app as possible, so we can get that compile time feedback. And what we hope is that in the end, users will spend a lot more time interfacing with our app and a lot less time seeing the home screen because the app crashed due to some unexpected bad input. Now, we know that we want to transition to Swift, but we had to decide how to go about doing that. And we thought, well, maybe we will rewrite the app. And this is a really attractive option at first because we can immediately get started using those new Swift-only language features. And this is going to help us make a lot of progress towards our goal of being able to give all that information to Swift and get all that compile time feedback. But this takes a pretty serious immediate toll in terms of the amount of time we can spend work on new features and updates for the app, things that we already have planned, because we're going to have to stop what we're doing and spend a lot of time converting the whole app from Objective-C to Swift. And like I said, we've been working on this app since 2008, so there's a lot of Objective-C. So we decided to go about this in a more piecemeal fashion, and basically just take it one feature at a time. And this is really great for us because a lot of us had never written any Swift before. We were pretty new, and we're all kind of starting over a little bit. So this gave us a lot of time to just generally become more comfortable and more knowledgeable writing Swift. But this does have that short-term cost of we can't really start off using those new Swift-only language features because, at least in the near term, the Objective-C part of our app is going to have to be able to interface with those new features we're writing in Swift. But we decided we were OK with this short-term cost. So that's what I'm going to talk about today, is some of the issues and lessons learned around working in an Objective-C code base and transitioning to Swift. And I'm going to quickly just start off by going over some of the basics around how Swift interacts with Objective-C. And then once we have that down, I'm going to talk about how you can make some tweaks to your headers in Objective-C to make your life a lot easier in Swift. And then finally, once we have those basics down, I'm going to talk about some of the issues and lessons learned around nullability, especially when Swift and Objective-C have to work together on that. All right, so first, I want to tell you about how Swift sees Objective-C. How does Swift work with Objective-C, the existing Objective-C that you might already have? And to talk about this, I want to start by going over where we started back in January of this year when we got started. So obviously we have a lot of Objective-C, and we don't have any Swift. And we know that this new Swift code that we're going to write is going to want to use a lot of that existing Objective-C code that we had because we have a lot of core common components and utilities that we use throughout the app, right? And to do this in any mixed language project, you need to add a bridging header. And a bridging header is just the place where you go to import all of the headers that you want the Swift side of your project to be able to see. And if you don't add headers here, Swift will have no knowledge at all of those headers in your project. And for the Yelp app, we decided that at least getting started, we were going to auto-generate this header by filling it with all of the headers in our app. Now, there are a couple motivating factors here. The first is, like I was telling you, we have a lot of these common core utilities and components that we use throughout the app, and we knew for some of us, all getting started on Swift at the same time, we wanted to avoid merge conflicts, all of us importing the same things. So that was helpful with that, but more importantly, like I said before, a lot of us had never written any Swift before, so this really allowed us to focus on writing new Swift code and not worrying about where things were on the Objective-C side of the app and what needed to be imported and what didn't. All right, so to talk more about what actually happens when you add a header to your bridging header, I've made a class for purposes of demo for my talk today called pet. Now, a pet, as you would expect, has a name, and pets also have a type, so maybe a dog or a cat or whatever other kind of pet you can imagine. And when you create a pet, you create it with a name and a type. And we can also parse pets from JSON, so we give it a JSON array, we get back an array of pets, and if there's some kind of error, that will come up through the error pointer there. And then finally, you can train your pet. And if there's some kind of issue training your pet, we also have the error pointer there for that as well. Now, when you take the pet header and drop it into your bridging header, what Swift sees is this. We have the pet class, and it has all of the same properties and methods that you would expect it to have. But there are a couple of interesting things I want to call out here. And the first is, all of the pointers have been bridged as implicitly unwrapped optionals. And if you're used to working in Swift, this is less than ideal, but at this point it's pretty honest because we haven't given Swift any information about if these pointers are optional or not optional. So this is the best Swift can do at this point. And then we have our collections. So this JSON array, I know it's going to be an array of dictionaries where each dictionary represents some information about a pet. But again, we haven't given Swift that information, so the best it can do is say it's an array of something. And then same for the return value here. We know it's going to return an array of pets based on the method name, but we haven't given Swift that information yet. Now, something nice that we did get out of the box without changing anything is that all of our error pointers are gone. Instead of having to deal with error pointers in Swift, which isn't so great, now all of our methods that had error pointers have become throwing, which is pretty nice to work with in Swift. All right, so to quickly recap, unless you give any extra information, the way it works is that all of your pointers are going to be bridged as implicitly unwrapped optionals, and all of your collection types are going to be collections of any. But, like I said before, we did get that benefit of our error pointers are gone, and those are going to be throwing methods now. Now, the good news here is that for those cases that we don't like so much, like the implicitly unwrapped optionals and those collections of any, that's something that we can change. We can change Swift's point of view. We can change how it sees the Objective-C side of the app. And so that's what I'm going to show you in my next section, is how you can make some small changes to the Objective-C side of your app to make your life easier in Swift. But it's not just about making your life easier in Swift. Our goal here is really to more accurately communicate what's going on in Objective-C to the Swift type system and get a better representation of that there. And we're going to do that using this three-part checklist. First, we're going to consider nullability. So instead of implicitly unwrapped optionals, we want to either pick one, either optional or non-optional for all of our pointers. And then we're going to consider collection types. So instead of arrays of any, we want to have arrays of pets or JSON dictionaries. And then finally, we need to consider, are there any cases where there was any lost API information? And what I mean by that is, are there any cases where the method in Objective-C, when you use it in Objective-C, some of the return states might be different when you actually go to use them in Swift? And that's something that doesn't happen very often, but it's something that you want to be aware of. All right, so just to recap, this is where we left off with our pet class. We have all of these implicitly unwrapped optionals that we don't really like, and we have these collection types, our JSON array and the array that we know should be pets, and those are some changes that we know we want to make at least getting started. And the first stop on our checklist here is nullability. Now, before we get started making any changes, I just want to quickly go over the tools we have to do this, and those are nullability annotations. And nullability annotations are just keywords that you can use to mark up your Objective-C so that Swift understands whether your types are optional or non-optional. And so the first annotation we have is nullable, and that just means that your pointer can't be null, and that will be bridged as an optional type. And then we have non-null, which means the pointer cannot be null, and those will be bridged as non-optional types. Now, there are two others that I want to mention just for completeness, but they're not all that useful when you're trying to make improvements here, and those are null resettable and null unspecified. Now, these might be semantically useful in some way in the Objective-C side of your code base, but in terms of Swift, those are still going to be bridged as implicitly unwrapped optionals, so they're not going to help you if you're trying to make any improvements in terms of making your life easier in Swift. All right, so now that we have some tools to make things happen here, let's go back to our Objective-C header. So here we have the interface for our pet in Objective-C. And the first thing I always do when tackling nullability in an Objective-C header is I go ahead and add these two markers. NSAssume non-null begin and NSAssume non-null end. And all that means is that it's going to assume that everything between those markers is non-null. And this makes our job a lot easier because now all you have to do is go through and mark everything that might be null. And in this case, that's just going to be our error pointers. So we can mark those as nullable because it's okay if you pass nil here. That just means that you don't care about doing any error handling. All right, so now that we made our first round of nullability changes, we can go back to our pet header and see what it looks like. And we can see we've already made a lot of progress. All of our implicitly unwrapped optionals, all those exclamation points are gone. And we're already making some good progress. But something interesting here did change that we don't really like. And that is our pets from JSON method, which used to be throwing, all of a sudden that error pointer is back, and we don't really like dealing with that in Swift. And the reason this happened is because when I added those NSAssume non-null begin and end markers, that marked the pets array return value as non-null. Now, in Swift, if a method throws, if it actually throws an error, it's not going to return a result. And so to fix that, we have to mark this appropriately as nullable so that Swift can safely bridge it as throwing again. So to do that, we just go back to our Objective-C header, and this is pretty straightforward. We just mark our NSArray return value as nullable. And then when we head back over to Swift, we can see it's throwing again, and that pretty much covers it for all of the changes we need to make for nullability. So we're already well on our way here, and the next thing on our checklist is collections. So we have this JSON array, which I know is going to be an array of dictionaries where each dictionary represents some information about a pet. And when we parse this out, it's going to return an array of pets, not an array of any. And to do this, let's head back over to our Objective-C interface. And our tools here are generics. So in Objective-C, we can go ahead and add some generics to our collections, and that will make these bridge properly to Swift. So we can start by just marking our return value as an array of pets. And then for our JSON dictionary, that will be an array of dictionary where each dictionary has string keys and ID values. Now that ID is going to be bridged to an any type in Swift, and that's actually okay here because that's accurate. The type of the value is going to be dependent on the key, and that's what we expect. So this is a much better situation. All right, and if we go back to Swift, we can see we now properly have, instead of an array of any, we have an array of dictionaries for our JSON array, and it returns an array of pets. So in general, this is a lot more useful to use in Swift now. All right, and that pretty much covers it for collection. So this is pretty straightforward, and if it turns out that tackling nullability in your Objective-C header is a really big task because it's a huge header or something like that, collections is always a good way to get started because you can make those changes kind of piecemeal without having to deal with any extra compile warnings or anything like that. Right, so the next thing we want to cover is if there's any lost API information when our Objective-C header was bridged to Swift. And so to show you what I mean by this, I had this train method here, and it implicitly returns void. And I've gone ahead and showing you this here so you can see. And if we can compare this side by side to the method in Objective-C, we can see that in Objective-C it returns a flag. And in this case, the flag has an important meaning. That flag, when it's set to yes, means the pet can be trained more, and if it's set to no, then the pet is tired or something. So in this case, we have loss of information because in Swift, the train method was bridged to have a void return value. Now, my case here is a bit atypical because in most cases, when you have a Boolean result and an error parameter in Objective-C, that Boolean result is usually there to mean success or failure. So if the flag is set, then you usually don't have an error set, and if the flag is not set, you usually do have an error. So that's why Swift thought it was safe to bridge it this way. But it is useful to consider that these are a little bit different if you encounter this in your code. And so if we can compare these side by side, we can see that the Objective-C method actually has 4 end states compared to the Swift's 2. In Objective-C, it can return yes or no, and in either case, it can have an error or no error. Whereas in Swift, it doesn't have a return value, and it could throw an error or not throw an error. And so if we want to actually go about fixing this, we don't have that many options in terms of any tools like nullability annotations or generics or anything like that. So what I opted to do for this example was to just make a small change to the type signature here, or the method signature. And I just went ahead and changed this to something that I knew would bridge really well to Swift, and that is give it a completion block. And the completion block will have both the error and the flag information, and that will bridge to Swift no problem. And it bridges as a closure, so now in Swift, we have this train method, returns void just like it did before, but now it has a completion closure, and that contains all of the error information that I was missing out on before. And like I said, this case is a bit atypical for Objective-C methods that return a flag and set an error, but it is something that's good to be aware of when looking at converting an Objective-C code base to Swift. All right, so that was the last step on our checklist, and we've already made a lot of headway in terms of making our lives easier in Swift. We have this pet interface that doesn't have any more of the implicitly unwrapped optional types, and we've done a good job of marking up our collections as well. And so, not only do we make our lives easier, again, we more accurately communicated what was going on in our Objective-C header to Swift, and we did that using our checklist by just going through nullability, picking optional or non-optional for all of our pointers. We went through our collection types and told Swift what we expected to actually be in those collections, so we didn't have to deal with arrays of any. And then for lost API information, we made a few minor changes there as well. Now to show you what this code actually means in terms of the Swift code you're going to write, I have just a short example here that first shows some code written in Swift as if we had not made any of these changes. So here I have some code that uses the pets.json method to parse out an array of pets. And then I have a for loop where I just loop through the pets, try to train the pet, and print out some information if if the pet can't be trained for some reason, right? So there are a couple of things that I want to call out here. And the first is, each time through the loop, since we initially started out having to deal with arrays of any, we're going to have to start by casting this to a pet type. Because if it's not a pet type, we're going to have to bail out and something horrible went wrong. And then when we go and try to train the pet, we don't know if we can train the pet any further because we don't have that return value. That's that missing API information I was talking about. And then finally, when we deal with some kind of error condition, if we want to print out the pet's name, we have to explicitly unwrap it, even though we know that all pets have names. All right, now when we go and make these couple minor tweaks to our pet class, what we get is code that is a lot nicer, and it looks like this. Each time through the loop, we have no more casting. And when we train the pet, all of the information about what happened when we trained the pet is right there in the completion block. And if there's some kind of error, we can print out the pet's name without having to unwrap it. So overall, this is a much better improvement. So in general, what you hope to get out of this is cleaner and hopefully safer Swift. But also, if you're a library author, it's really nice to know these tools are here because even if your library is still in Objective-C, you can make these tweaks and have an Objective-C library that is still pretty nice to use in Swift. And this is really attractive, at least right now, while the Swift API isn't stable, because you won't require that your clients, if they haven't converted to Swift yet as well, they won't have to distribute the Swift standard library and other associated libraries with their application, because now your library requires Swift. So just something to keep in mind, and especially why you might see that some libraries are still running on Objective-C. All right, so now that we have a pretty good understanding of how Swift works with Objective-C and how we can make some small tweaks to our headers to make our lives easier in Swift, I want to talk about some of the issues and lessons learned around nullability, especially when Swift and Objective-C have to work together on that. And I'm going to start just by considering this one line of code. Here I'm trying to assign nil to a string. And this is going to give you a compiler error in Swift because this kind of string is non-optional, so it doesn't allow nils. But in Objective-C, you can still do this. Here I create a nil string, and I try to assign it to a string that I've explicitly marked as not null, and this will compile just fine. Now imagine this is a less trivial example where I've managed to get nil into a property like the pet's name, where I have told Swift that I basically promised that that pet's name will never be nil. If you do this, some really bad things will happen. Since Swift is going to blindly trust that you'll never get nil into the pet's name, and when it tries to access the name, if there's nil in there, it's going to crash at runtime. Now the good news is that because we've gone ahead and marked up our code with all these nullability annotations, you can kind of lean on the Objective-C static analyzer to help your Objective-C, help your Swift, and tell you when you might have broken this contract. But just generally, adding nullability annotations is a good idea in your code because you're telling the analyzer what your expectations are. And generally, the static analyzer will basically tell you that, hey, you might have, this expectation that you've set by adding these nullability annotations no longer holds up. So it's important to understand that when you're dealing with nullability annotations in Objective-C, it's just a contract with Swift, and it will blindly trust you. So don't lie to it. All right, so now I want to talk about a slightly different nullability issue that we encountered while converting the Yelp app to Swift 3. And to do that, I've made this pet interface where I've added some new helpers for training pets. And so the first is this dog name method that returns a new trainable pet. And we have this train pets method that takes an array of pets, and that method just loops through the array and calls train on each of the pets. Pretty simple. Now note here that I haven't added any nullability annotations. So this suffers from the same problem we started out with our pet class. We have implicitly unwrapped optionals everywhere, and we have our array of any. Now I've written some code that uses this to demonstrate a few things. And here I'm just creating a dog named Fido, and then I'm wrapping Fido in an array and passing him to train pets. Now if we take a closer look at what's going on here, we can see that because I haven't added the nullability annotations, that pet instance is an implicitly unwrapped optional. But in Swift 3, this is really just an optional because implicitly unwrapped optionals are no longer really part of the type system in the same way. And so then what we're doing is we're taking this optional pet, wrapping it in an array, and passing it to a place that takes an array of any. But that's a non-optional any. So what we've done is we've somehow coerced this pet, this optional type, to a place that takes a non-optional type. And this is a problem because now we've, again, that contract about nullability I was talking about earlier, we've broken that using Objective-C, of course. And what will happen is actually in Swift 3, when that coercion takes place, it actually changes the underlying type to something that's not a pet, and so now you can no longer call train on pet, and that's going to crash. And this is really hard to spot because in Swift 3 there are no compiler errors or warnings about this. Luckily now in Swift 3.01 there is a warning explicitly for this. So the point here and the takeaway is that just like any major software release, there are bound to be bugs that are fixed right after the major software release, and so it's a good idea to follow along and pay attention to email digests and things like that to make sure you're staying on top of what's coming next. So here, it's a good idea to build against Swift 3.01 even if you're not planning on distributing with it yet, since it's not fully released. Now the good news is that at least for this, there's a pretty easy fix. You can either add nullability annotations or collection type info or both to give Swift enough type information to figure out the right thing to do. All right, and that's pretty much all I have for today. Just quickly go over what we talked about. Swift's default view of Objective-C is pretty honest. If you don't give it any other extra information, you're going to get implicitly unwrapped types because Swift doesn't really know if things are optional or non-optional, for example. So it's a good idea to go ahead and add nullability and collection type information to your headers to make your life easier in Swift, but also more accurately communicate to the Swift type system what's going on in your Objective-C APIs. And then finally, be cautious about promises that you make from Objective-C. If you say that a property or something is going to be non-optional, Swift is going to blindly trust you there, and it'll crash at runtime if you're ever wrong. And then finally, like I said, with any major software release, it's good to stay on top of any bugs or issues that came out after it to better help the health of your code. All right, so that's all I have for today. Take any questions now if you have any.
If you do have any questions, there are 2 microphones on either side of the stage. Okay.
Hey.
What kind of performance impacts did you see from including every single header?
Yes. So initially, there weren't that many. In terms of build time, it didn't have that much of an effect. So our app now has roughly 900 or so, almost 1,000 Swift files. And once you're getting to that point, it really, touching any Objective-C code and then having the full app recompile, it gets really old. So a couple of weeks ago, we just went through and got rid of the auto-generation script and then went through and added all the headers. And now it's down to about 300 headers. And things are a lot better. So it did affect us eventually, but getting started, it's no issue, probably for about a couple months. Cool. Anything else? Anything else about the Swift transition? Yes. Do you want to go to the microphone? Oh, you're in the middle.
Please check. I want to ask about, is there any, you said that you have lots of .m file and .h files, right? And you have to add the assume null begin and end, start and end, right?
Yes.
And yeah, something like that. Do you have any internal tools to, generate all those non-nulls and begin and end and automate it so that it's just like one run you can just adding all of it, or do you do that manually of some sort? Thank you.
Sure. Yeah. So I think the question was, do we have any internal tools to sort of automate the process of adding nullability annotations, right? Cool. So we don't have any tools to automatically add those. My opinion is it's a little bit dangerous just because, like I said, if you promise that something is going to be non-null, Swift will trust that, and you won't get any warnings or anything if you, if there happens to be a null value in there. So we've actually, it's been a pretty slow process. And so, for example, the business object, which is a pretty commonly used header in an app that deals with businesses, still doesn't have nullability annotations because it has like 130 some properties, and auditing all of those is really hard. So it's really hard. It's a hard problem. Something we have done is something like, so when we realized that this implicit coercion from optional to any was going to be a big issue, we audited we wrote some scripts to audit all of the collections in all of the headers, in all the public headers that we added to the bridging header to just try and get ahead of that issue before we shipped Swift 3 in the app. Since you can add collection types kind of piecemeal without getting any compiler warnings about places that you haven't done it. Hey.
Hi. Hi. Is this working? Okay. How much of the app have you transitioned to Swift? And do you foresee a 100% transition? That's my first question.
Sure.
And secondly, was there anything that was worst off in terms of performance-wise or code clarity in Swift? Or if there's none, say so as well.
What, sorry, can you repeat the last question?
Was there anything worst off after the transition? It actually worked better in Objective-C in terms of performance or code clarity?
Like build performance or the app
compile time or runtime, yep.
Okay. Yeah, builds have gotten slower. The Objective-C app has, so before we started, and I still don't really fully understand how we did this, but like we still have between 2,000 and 2,500 .ms, and even after adding almost 1,000 Swift files, that's still the case. I don't know why. Yeah, so that slowed down our build times. I mean, the app used to take like 2 to 3 minutes to build. Now building the main target takes 7 minutes or 7.5. So that was, that kind of hurts a little bit, but we've been able to make some improvements there, incremental things, and we've done some work to try and debug what's going on and report issues to the Swift team. Remind the second question.
Runtime.
Runtime issues?
Yeah.
Oh, we haven't noticed any so the biggest runtime issue was places where we accidentally unwrapped something that, it was really in Swift 2 when we had implicitly unwrapped optionals and we assumed something would be there, and that caused a lot of crashes, especially with the business object. But yeah, that was the main issue that we saw. We didn't see any like runtime performance issues that I know of.
And the percentage of transition, like.
Oh, percentage of transition, yes. Yeah, so like I said, somehow we're still between 2,000 and 2,500 Objective-C files, even though we've added 1,000 Swift, so I don't know. I mean, the math there should be like a quarter or something, or a half. But I think we're like maybe 10% of the way done. It's going to be a while before the Yelp app is fully on Swift, because we just have features that have been in the app for a long time and don't, we don't have, and like the team is really new, so there's some features that are just very hard to convert in terms of like having knowledge of all of the little pieces and details of each of the features, yeah.
Hey, sorry, I have one question. Actually, 2 questions, actually. First question is, for code in Objective-C that is calling Swift code, do you guys follow any conventions? Because a lot of Swift constructs are not available in Objective-C. Then would you have an interfacing layer, or would you dumb down the level of Swift that you are using in order to remain compatible with Objective-C? And the second question is, because you need to maintain your contract on Objective-C side yourself at runtime, do you run any static analyzer tools? Like Facebook has a flow tool, for example, that will analyze. I'm not sure if it helps with nullability and analysis, but do you guys run any static analysis tools to help you with this?
Yeah, so I mentioned, so for the static analysis question, I mentioned we use the Clang static analyzer and try and use that as much as possible. For the first, what was the first question again, sorry?
Objective-C code, when you're calling Swift code in Objective-C
yes. Okay, so what we try to do is use these, at least at this point when we're, so all of our new features and new code added to the app is all Swift. We actually have a pre-commit hook that doesn't allow you to add new .ms. Yeah, and then so what we do is we try to use Swift features as much as possible and kind of ignore the Objective-C side of the app if we can. And then when the Objective-C side of the app has to interface with Swift, we add some kind of translation layer where in Swift, we write the name as like, method name, Objective-C only, and then do @objc, the actual method name that's Objective-C sees, so that it's pretty clear where things can get cleaned up once the Objective-C side goes away, because we act on the assumption that the Objective-C side is temporary at this point.
We'll do one more question.
Okay. So in your example, like the train method, you changed the method signature, right?
Yes.
So how would that in turn affect all your like wrappers or method that uses that particular function?
Yeah. So I mean it's gonna not compile. Yeah. And so yeah, that's it's a problem that you might run into. But like I said, this case is kind of atypical, but I just wanted to call it out because at least in our code base, we have seen it before, and I thought it was worth calling out. But yes, it's like I said, it's the change that you don't really want to make too much because then it takes your small nullability change and blows it up into something that you didn't want it to be.
Ask the final question. So I'm sure everyone here has some form of experience with Swift migration. It's not always the easiest thing going from Swift 1 to 1.1 to 1.5 to
Sure.
2 to 2.5 and everything. And especially when you work for a big company with like 20 engineers and thousands of lines of code. How do you manage that from a logistic point of view? Like, does one person do all the migration and then you commit that, or like how do
Sure.
you handle Swift?
So I'll tell you the two migrations that I've been at Yelp for. The first was migrating to Arc, which happened about 2 years ago. Shockingly, I know. And basically, one person did the initial running the script, and then we had like a spreadsheet that we went through all of those files and code reviewed them in groups of 10 or something like that, and just put check marks next to them in Google Docs. Yeah. So the way I did, I did the migration from Swift 2 to 3. And the way we did that is I ran the tool, and then it took 3 days to get rid of all the fix-its and have the app build. And then so we use a tool called Review Board. I don't know if a lot of what people use for code review here. But basically, we have an internal Review Board instance, and we have some Python tools around that. And what I did for doing code review is, so we had like 700 files change, and I bucketed those into 50 each. And I wrote some tools that anytime that would basically post one code review per set of 50 files, and then anytime I changed some code, it would only update the code reviews for the code that I changed. So I basically wrote some toolings so that I could split up the code review into something manageable, and then the code review got done in like a couple, like 2 days, 2 to 3 days, spread out across the team of like 10 reviewers. Yeah.
Thank you, Ben. Can we have a round of applause for Ben, please? Thank you.